Hello and welcome back friend. This is our 12th class and it is all about a start air system. In order to understand in better way, I have included fundamental of pneumatic and hydraulic. This is for those who are at very beginning level or are pursuing their engineering or are serving at junior level on board ship. This will facilitate them to understand the overall concept of the start air system, reading pneumatics diagram and hence for troubleshooting. Also this chapter is little bit large, therefore I have divided it into two parts, part 1 and part 2. In part 1 I have covered fundamental of pneumatics and hydraulics, and in second part we will learn about ME engine start air system. So let's get started. Learning objective. So following thing we will learn in part 1: what is pneumatics, symbols and terminology, understanding of some valve function with animation, how to read pneumatic diagram, understanding of maneuvering diagrams, air start lines component, and in part 2 we will learn how to check starting air valve integrative function test of air starting valves, understanding maneuvering diagram with animation, troubleshooting on various topic, case study. So these things we are going to learn in this topic. So we are going to start with part 1. First thing is pneumatics. It is a branch of engineering that makes use of pressurized gas or air, which in turn converts into useful mechanical work. Pressurized gases are mostly inert gas. Here we will talk about system which runs on pressurized or compressed air of 30 bar and control air of 7 bar. So we are going to learn about the symbols as well in this topic. So here we will discuss about all important symbol which enables better understanding about pneumatic valves, their working procedures, reading pneumatic diagram and troubleshooting. So related to symbol, I am just going to give some disclosure that first of all I want to emphasize that all these symbols which we are going to learn just now are just for understanding purpose, and there is no hard and fast rule that they will be used as it is for the purpose they are made for. So little bit here and there can be acceptable. So we are going to learn about the basic symbol of pneumatic and hydraulics. So what are the basic symbol of pneumatic and hydraulics? For pneumatic the basic symbol is white background, and for hydraulics basic symbol is black background. So white background is for pneumatic and black background for the hydraulic, and mostly in both cases, means in pneumatic and in hydraulics, triangle are used, and these triangles are used for showing power, flow, exhaust and drain. Exhaust in the case of pneumatic and drain in the case of hydraulic. Now I am taking you to the hydraulic and pneumatic circuits where you can understand in better way. These circuits I will explain later on and I will show with animation as well. This is the hydraulic circuit and this is pneumatic circuit. In pneumatic you can see white background is there. This is showing actually source, and in hydraulic you can see this black triangle is present. Also here two black triangles are present in this reversible type motor. So that is the hydraulic circuit. In pneumatic you will find these white triangles here also. So this is the pneumatic circuit. About this source means any pipeline from where the air is being supplied to this valve. For example, this sort of reservoir is there, that is the main source, and from here the air is coming from this pipeline. So this white circle is showing these pipelines. Okay, now moving next. Here again I have taken two circuits diagram, one for hydraulic and another for pneumatic. In hydraulic diagram you can see this black triangle, and in pneumatic diagram you can see this is showing the reservoir tank, and white triangle means pneumatic. Here also the compressor is having the white triangle. Here I want to emphasize on one thing, that in hydraulic circuit you will find this tank symbol everywhere. Here you can see, here as well as here. So at various place you will find this symbol tank, and in pneumatic diagram you will find this symbol which is showing the exhaust. Exhaust means air is being released to the environment. So now I am going to show you that what sort of this symbol look like actually. So this is hydraulic tank and this is the sintered filter, which is basically used on solenoid valve in order to release the air. The air comes from here and it is released from this sintered filter. In hydraulic tank, the hydraulic return line comes from here. There is a filter inside, and after filtration the oil is sent into the tank and supply is given from this sort of connections. You will also find thermometer which show the temperature of hydraulic oil. Now we are going to see some valve familiarization. We are going to get familiarized about solenoid valves, part name, nomenclature of the valves. This is the picture of solenoid valve. This part is called solenoid, this part is called the spool, and this protruded part is called the land, which basically cover or uncover the port. This part which is basically opening in the bodies are called the ports, and the outer side metallic part is called the case. You will find always one or two spring in the solenoid valves. Now I am going to show you with the help of animation that how this valve actually work. So this is the animation, and when this solenoid is getting energized, then a spool is pushed to the right side and hence the port of air input is uncovered and air is allowed to move to other side. In this picture here you can see that this is shown with some green color. The meaning of this green color is that in idle condition this port is actually pressurized with the air, and hence this port is called the primary port, or we can say the port number 1. I hope this is clear. So by seeing this valve we can understand that it has 3 ports, means number 1, 2 and 3. 3 ports, 3 openings are there, so 3 ports are there, and it can work in 2 position, that means two-way valve. Here this was the 1 position, and here the extreme right of the spool position was the 2nd position, that means it has 2 position. So this valve will be nomenclature as 3/2 direction control valve. How will you remember? Higher digit first, lower digit next. Higher digit is representing port and lower digit is representing position. Always remember that number of port will be always higher than that of the position. Now moving next, in any directional control valve, number of position is denoted by number of square or rectangle box. So this is showing 1 square box, that means one way. This is showing 2 square box, that means two-way valve. Now I am going to show you with the animation that how this two-way valve look like. So you can see there are 2 port, port number 1 and port number 2, and position is 2, extreme left and this extreme right. So in one position the air is allowed to pass to the number 2 port, and in another position air is blocked. This symbol is showing that air is blocked, and this symbol is showing that air is allowed to pass. So this valve will be nomenclature as 2/2-way valve, that means 2 port and 2 position. Moving next, this is 3 box, that means 3-way, and here you can see with the help of animation that 3 position are extreme left, in middle and extreme right. This valve has 4 port, 1, 2, 3 and 4, and position are 3. So this valve will be nomenclature as 4/3-way valve. In another way, this valve can be nomenclature as 4-port 3-way valve and 4-port 3-position valve. And all these sort of valves are called direction control valve. In short, these are called the DC valve. Taking you to the other symbols related to direction control valve. This is showing 2 port and 2 position valve. First digit is showing port and second digit is showing position. Okay, next in this picture 2 square, that means 2 position, and there are 3 port, 1, 2 and 3. So this valve will be called 3 by 2 direction control valve, and it is written over here normally closed and here normally open. I will tell later on what actually is this. In this picture you can see there are two rectangle basically. Here you can see this is a square, but here it is represented with rectangle. So whether it is a square or rectangle, it doesn't matter. Okay, now here again 3 ports are there and 2 rectangle, that means 2 position. So this valve will be also called 3 by 2 direction control valve, and it is normally open. Next, in this picture there are 4 port, 1, 2, 3 and 4, and there are 2 rectangle. So this valve will be called 4 by 2 direction control valve. 1/P means primary port or air inlet. Air inlet means here you can see 1 and P is written, that means main air supply will be connected to this position. A and B are working port for actuator, pneumatic motor or valve, pilot air, etc., which ultimately converts pressurized air into useful works. So now I am going to show you that how this A and B port look like. Suppose this is a direction control valve and this is actuator. So the port in which the actuator connection are given, that ports are called the A and B, and this A and B port are oftenly termed as the working port. E and R means exhaust or return port from which air get released into the atmosphere or to another unit. For example, you can see here this R is written over here, means this line is return line or exhaust line. Somewhere you will find written E. E means it is exhausted into the atmosphere. In this picture you can see there are 2 sintered filters present. So these 2 filters representing E means exhaust. This is called the P port. Here you can see P port is written, and these 2 are working port, that means any actuator, motor, etc. will be connected from these 2 ports. So here you can see A and B are written. Extra line shows pipe works fitting. This also expresses the default position of valve. For example, you can see over here that lines are present. This line basically represent pipe and also showing that this is the default condition of that valve. If I take this valve as an example, then I will see that in default condition the pressurized air is staying over here. It is not allowed to pass through the another port, and this number 2 port is connected to number 3 port, and this number 3 port is either going to some other valve or it is being released into the atmosphere. So I hope this is clear. Now I am going to discuss about this normally closed and normally open. Normally closed, that means in default condition the pressurized air is not allowed to pass to the other port. Meaning of close is airflow is stopped. Next, normally open means in default condition the pressurized air is allowed to pass through the another port and this return port is blocked. So I hope this is clear that what is the meaning of normally closed and normally open. So now you can see the example. Suppose this is a valve and this is the pipeline. So these pipelines are represented like this. Now I am going to show you one solenoid valve and we will discuss some properties of that valve based on this figure. So this is the solenoid valve. This solenoid valve has 5 ports, 1, 2, 3, 4 and 5. Also we can see that in this default condition, that means when the solenoid is not energized, this is the default condition, and in this condition number 1 port is open to number 2 port. That means this valve is normally open type, okay, and number 2 and number 4 port are used as a and B port, means working port. Number 5 port and number 3 port are used as a venting port. And here this is the graphical representation of this valve. This arrow is showing that this is the electrically operated valve. So this is basically representing the solenoid coils, okay. And another one is this white symbol is showing that this spool is being operated by the air. I will show you in the animation that how this valve is being operated by the air, and these are showing direction of the airflow in the two different position. Also, I want to tell you one thing, that in this picture you can see there are two-way arrow is present, and in this picture you can see only one way the arrow is present. In two-way arrow meaning is the air can allow to flow in both direction. Okay, you can feed the air pressure over here and it can escape from here. You can feed air from here and it can escape from here. But here the air is allowed only from this port to this port. That means from number 1 port to 2 port. Air cannot be allowed to flow from 2 port to 1 port because there are some restrictions based on the design. Next example, this picture is showing that this valve is related with the hydraulic, because here T symbol is used. T symbol means tank. Tank means hydraulic tank. So it is not being used for the pneumatic purpose. Okay, but here we will see some other thing, that lands on valve spool block passage. This land basically blocks passage between two ports, and this groove between two lands allow to flow the air or oil between two ports. Here you can see that there are actually 5 number of ports, A and B, which are working port, and this T means drain port, and this is main pressure port. So it should be 5 by 2A valve because there are 5 ports and 2 positions, this position and this position, but here it is written 4 by 2A valve. But question is why? Because when these two T ports are internally connected, then these two ports are considered as one port. That's why here it is written 4 by 2A valve. Once again, I want to give you some example related to normally closed type and normally open type valve. As I told you before, that in normally closed type, number 1 port, since it is primary port, means pressure is present over there, and you can see in this normally closed type, number 1 port is closed by this valve, and number 2 and number 3 port is still open. So that is called the normally closed type. In normally open type, you can see number 1 port is connected to number 2 port. That means pressurized gas is allowed to flow to other ports. That is called the normally open type. I hope this is clear. Now we are going to see a different method of spool operation. So here we are going to discuss about the different method by which we can operate the spool which is situated inside the valve. First one is electrical, second one is pneumatic and hydraulic, third one is mechanical, and fourth one is manual. Now we are going to discuss each and every method in detail. So first one is electrical. As we know that the pneumatic or hydraulic valve is operated by the solenoid valve, and this symbol is for electrical. In electrical method, there are two type of spool operation. First one is solenoid direct and another one is solenoid pilot. We will see the example of solenoid direct and solenoid pilot. Next, here in this picture, I want to just give briefing of proportional valve. I have taken the example of hydraulic valve. Here it is written P and T, that means it is hydraulic valve. Proportional valve, that means the electrical signal can be varied. In hydraulic or in pneumatic, if you can alter the value of flow of air or flow of electrical signal, then it is denoted by with this arrow. This arrow can be in downward direction or can be in upward direction. Here it is present on this electrical line. That means we can control the amount of electrical flow inside the solenoid valve. So that is called the proportional valve. Other meaning of the proportional valve is, you can see these two lines present over here. The meaning of this line is the spool which is used inside the valve is of proportional type. Now I am going to show you what is solenoid direct. In this picture you can see that this is a solenoid valve, and in the solenoid valve there is a spindle. This spindle is directly connected to the spool. That means the spool movement is being controlled by the solenoid. So that is called the solenoid direct. That means solenoid valve's spindle is directly connected to spool, and hence solenoid is directly controlling the movement of the spool. Now I am going to show you the solenoid direct with animation. You can see that when this solenoid will energize, it will direct move the spool towards the right side, and hence the direction of flow of air will be changed. So that is called the solenoid direct. Now next method is pneumatic and hydraulic. That means the spool position is being controlled by either pneumatic or by hydraulic. In this picture you can see that hydraulic or pneumatic air pressure is acting over here or from here, and it causes to movement of the spool in either left side or in right side, and hence controlling the movement of the flow of air or oil. That is called the spool operation, which is driven by the pneumatic or hydraulic. This is the graphical representation of this valve. Here you can see white triangle. That means this valve's spool is being operated by the pneumatic. This is the picture of ME engine maneuvering diagram. Here I want to show you that in this maneuvering diagram, some valves are electrically operated and some valves are pneumatically operated. So here in this valve you can see tilted line is there, that means it is electrically operated, whereas this valve is pneumatically operated. Now we have understood that why I am discussing over the different methods of spool operation, because this is going to help you in order to understand the pneumatic or hydraulic diagram. Second type, slip type valve. What is slip type valve? In slip type valve, the spool is not situated inside the body. Here you can see this is the body, this part is body, but there is a additional part fitted which is called the slip, which looks like this, and spool travels inside this slip part, and this sort of opening are basically indicating the ports. So here these are the port, these openings are basically port. In this graphical representation you can see pilot air is being fed from here as well as from here, main air is working over here, and these are the two exhaust line. These valves are very easy to do any sort of maintenance. So we are continuing. Next is electrical, pneumatic, hydraulic. That means our prime power source will be electrical, and then the electrical signal will allow pneumatic or hydraulic to move the spool. So indirectly we are going to discuss about the solenoid pilot. So first we are going to discuss about the pneumatic. So this is the example of solenoid pilot. Now I am going to present solenoid pilot and solenoid direct both, so that you can make out the differences. This is the solenoid direct, in which the spool is directly connected to the plunger of solenoid valve, and this is the solenoid pilot. In this valve, plunger is not directly connected to the spool. Solenoid direct graphical representation will be like this. That means this electrical signal is directly controlling the movement of the spool, and in solenoid pilot this sort of graphics symbol is used, in which first electrical signal will generate, then pneumatic signal will ultimately move the spool valve. Alright, moving next. Now I am going to show you with the help of animation how does this solenoid pilot work. First of all, I am going to explain. The pressurized pneumatic air will be available at number 1 port, that is called the power port, and you can see over here there is a tap which is basically connected to this chamber. That means when the pressurized air is present, automatically this will come to here, but this valve will not allow to pass the air into this chamber. This line is called the pilot line. Okay, and air which will comes out from this line we will call the pilot air. So as soon as the solenoid is energized, this plunger will be shifted to the left and it will open the valve, and hence pilot air will enter into this chamber and it will start pushing the spool up to extreme right direction. Now you can see actually. So first pressurized air is available. Now it will wait for here. When the solenoid is energized, this valve will lift and air will start entering into this chamber and will push spool to the extreme right. And when it will de-energize, air will release. There are so many holes present over here, so air will released and it will cause the spool to move to left position. So this is how the solenoid pilots work. I hope this is clear. Now moving next, electrical hydraulic. So this is the graphical representation of the electrical hydraulic valve. That means electrical, this is electrical, and this black triangle means hydraulic. That means the spool movement is finally controlled by the hydraulic pressure, not by electrical. And this valve is normally closed. Why normally closed? Because you can see this is the P port, that is the pressure port, and this pressure port is closed over here. So that is called the normally closed. Second, the same thing, electrical and hydraulic, but this time pressure port is present over here, and this pressure port is allowed to connect to other port. That means this valve is normally open type. Now I am representing one picture. This is the picture of electrical hydraulic type valve. In this valve there are actually two valves. One is called the pilot valve and another is called main valve. This pilot valve basically regulated by the electrical signal, and the pressurized oil is directed to operate the spool, and which is called the pilot oil. Now you can have doubt that suppose this is pressure port, so hydraulic oil will be acting over here. So how hydraulic oil is going to reach over here, because there is no any passage or holes are there. But in reality there is a passage which is drilled inside, which you cannot see in this illustration. This sort of passage are there, which basically allows pressurized oil to go into this pilot valve. And when this pilot valve will operate, then a small amount of hydraulic oil will act over here or over here, and hence the movement of a spool will be controlled. And this X is called external pilot, means you can block this line and you can open this port, you can have a externally pilotage. Similarly, this Y is called the external drain. In case you don't want to use this internal drain, then you can have other option, you can use external drain from this port Y. Continuing electrical hydraulic. So most of the time you will find electrical hydraulic valves like this, means both side solenoid are there and the spool is being operated by the hydraulic oil. This is the picture of hydraulic system of the ME engine. In this picture you can see that this is the main valve, which is called the FIVA valve, and this is the pilot valve, which I have just described before. This pilot valve is operated electrically. You can see this tilted line is there, and hydraulic oil is being regulated through this pilot valve. This is also called the Parker valve, and this hydraulic oil is going to pilotage this FIVA valve, which ultimately control the fuel injection and valve actuation. So this diagram I will show you with the animation, as well as also I will explain in detail later on. So now you can have a fair understanding about how this electrical hydraulic spool operation is being done. Now our next method of a spool operation is mechanical. In mechanical type there are several methods by which we can operate the spool, but here I am going to explain only two methods, that is number one cam operated and second lever operated, because only these two methods are used in any sort of main engine pneumatic diagrams. Here I am going to represent one picture in which you can see that these two valves are not being operated by electrically or by hydraulically, but these are being operated by pneumatically with help of this sort of mechanical arrangement. Now I am going to explain this figure little bit so that you can have a fair understanding. First of all, this is the symbol of source from which the pressurized air is coming. This is called the main line, and these dotted lines in blue colors are called pilot lines. Okay, this is 5/2A valve, about which I have just explained. Pilot air comes from here or from here, and then it's operate the spool and direction of flow of air get changes. Okay, these two valves are called check valves with restrictors. This is called restrictor and this is called check valve. Airflow occurs this way, means by lifting the valve and it goes all along this way. Opposite flow of air is restricted by this valve and it is allowed only to pass from this restrictor. And this symbol is showing that we can adjust the flow of the air passes through this valve, and hence we can control the movement of this piston. As for the function, I am just going to explain this valve. You can see this is the bigger cam which basically operates these two pneumatic valves, and it is controlling the pilot air which is going to this 5/2A valve, and accordingly the spool shifts and either the air flows through this valve or through this valve, and hence the pressurized air acts either from here or from here, and this whole piston gets shift from this place to this place, and all this function work automatically. Now I am going to show you same thing with help of animation so that you can understand in a better way. Now pilot air is going here because this valve is operated, and air is going through here and it is acting on the piston. Now as this cam moves, this valve is getting operated. Now pilot air will flow like this and it will change the fraction of air. Now air will go like this and it will again push the piston back to its original position. Now I am going to show you a picture which is the MC engine reversing mechanism. So this mechanism is somewhat resemble this animation, but unlike this animation, this system doesn't work automatically. The piston of this actuator shifts if and only if when reversing is required. That means from ahead to astern or from astern to ahead. So I hope this is clear. Now moving to our next method of a spool operation, that is called the manual. Regarding valve I will explain in a while, but here I want to explain a very important function which is also called a manual operation of the pneumatic valve. It can also be used in case of any emergency. So that is called the manual override, and graphical symbol of this manual override is this one. Now here you can see that this is the white triangle present, and here also white triangle present but with this line. Now the meaning of this white triangle is that when electrical current is available, then only pilot air will be available. I told you before that this is the symbol of electrical. First solenoid will energize, then pilot air will be available. But this symbol meaning is that pilot air is available all the time. The meaning of this triangle with this line. Okay. In another way, we can also represent by a white triangle. Now question is why this sort of system is used. This is used only to make the valve fail safe. I will explain later. Now I am going to show you some important points about this manual override. So first one is, in most of cases this is just an alternative of solenoid valve, not the power, that is pressurized air. If pressurized air is not available, this is not going to do anything. That means this manual override is just only a alternative of this solenoid valve. That means in order to shift the spool you need pneumatic pressure. In case you don't have pneumatic pressure, this is not going to work. Okay, next one is, this is used in case of solenoid valve is not working, burnt out, etc. But for that you have to have this pneumatic pressure. Next, can be used to check function test of the pneumatic valve. That means if suppose you have overhauled and you want to check the function before assembling, then just you can operate this one and you can have function test of this valve, that whether direction of flow of air is changing or not. Okay, now I am going to show you the picture of a solenoid valve. This manual override graphic representation look like this one. So this is the manual override button. This is the graphical representation of this valve. Here this white triangle is showing that at this end a constant pilot air pressure is available all the time, and this spring is showing that this valve is also a spring return type. That means when the solenoid valve is deactivated, the spool will shift to its default position. So as I told you that these two are used just to make this valve fail safe. Now moving next, I will show some more example over here. So this is a pneumatic valve. This is the manual overriding. Next, this is the manual overriding. Now I am going to show you some other pneumatic symbol which we have not discussed so far, and we are going to see in detail. So far we have seen about this main air supply, exhaust air or supply with this white triangle, pilot air which is represented with dotted line, and main lines which are represented with solid lines. Regarding these two symbols I will explain later on. Now we are going to see from here. So first one we will see about this symbol, that is called the air bleed. In most of the pneumatic line you will find the air bleed system is given at various locations. That means you have to open this screw and thereby some amount of air will be released, which will remove moisture as well as oil from the system. Now next is this 3/2A valve or other symbols we have already seen. Now next going to see all these three symbols. These all are called the mechanical type pneumatic valve. That means a spool operation will be done by mechanically or by manual. So first one is push button. Push button pneumatic valves look like this. Next one is plunger activator. So this is the plunger activator, symbol is here. Next one, lever activator. This is the lever activator. Now next, first one is roller activator. So this is the small roller. It can be of vertical type as well, but symbol will be like this. Next one is diaphragm activator. So this is a pneumatic valve. Basically there is a diaphragm, and diaphragm operated valves are of numerous type. If you want to know in detail, you can have a look on internet. Next one is solenoid activator, we have already seen. Regarding a spring return, we have also seen. Next we are going to see single acting and double acting. So this is a picture of single acting, in which you can see the air is only allowed to enter from one position, and it will act over this piston. It will push the piston against the spring force. Now showing the single acting cylinder and double acting cylinder both. So this is the single acting, air is acting only from one place. In the double acting, the both way air can operate, and this is the figure of double acting double rod. That means one rod is here and another rod is here. In this cylinder only one rod is there. Next, this one is 5/2 valve, we have already discussed. After that, these three symbols are left. Before discussing these three symbols, I want to explain about this restrictor. So now we will see in detail about this. This is the symbol of fixed orifice. In this fixed orifice, a drilled set screw or any other metal part which has a drill portion is used as a fixed orifice. That means amount of air or fluid will be restricted at this area. Okay, next one is this variable orifice. This symbol is showing that we can alter the flow of air or oil, and it can be done by manually. So this is the valve, and by rotating this knob we can actually alter the amount of flow of oil or air. So that is called the variable orifice. So now we are going to discuss about all these three symbols. So first one is reservoir. We have already seen, this is called the air reservoir. Next is unidirectional restrictor, which has a non-return valve as well as a orifice valve. Unidirectional restrictor valve look like this. Next is shuttle valve. This is also called check choke valve. There are 3 ports in this valve, in which there are 2 pressure port and 1 exit port. There is a ball inside this valve which chokes this port or this port. It's totally depend upon the which port is pressurized more than the other. Suppose this pressure port is pressurized than this one, then obviously this ball will choke this port and it will allow air to pass through this way. Similarly, if this has more pressure than this one, then this ball will choke this port and it will allow air to pass through this one. You will find at numerous places this shuttle valve is used in main engine maneuvering diagram. So this is a very important valve. It's look like this. Now we are going to discuss about a different topic, that is called the detent. The word detent has derived from word detention. The meaning of detention is holding. So in the context of this valve, the meaning of detention is to hold the spool at different position. This is the symbol of detent. One cut means it will be detained at one position. Two cut means it will be detained at two position. So now I am going to give a simple example by which you will be able to understand what is the function of detent. This is a lever operated valve. In order to get detent in the valve, there are some requirements. First requirement is there must be grooves in the spool. If you want 2 position detent, then you need 2 grooves. If you want 3 position detent, then you need 3 grooves, and so on. Second requirement is ball with spring, which actually holds the spool at one place. Third requirement is the spool should not be of a spring return type. You can see there is no spring placed over here. So these 3 requirements must be fulfilled in order to get the detent facility. In the above picture, the lever is in vertical position because the ball is in this groove. When I shift this lever, then ball comes out from the previous groove and it rests in the next groove, thereby keeps holding the spool at new position. So I hope this detent function is clear. Now we are going to see some more symbols related to pneumatic diagram. So here few symbols are there. So now we are going to discuss one by one. So first one is check valve. Check valve function is it allows flow in one direction and blocks flow in other direction. So I am showing one illustration. This is the check valve which doesn't have any spring. This is actually valve. If air or liquid comes from this side, due to liquid or gas pressure, this valve will sit over here and thereby it will restrict the flow of gas or fluid. But if gas or fluid comes from here, then it will shift the ball and ball will restrict over this sort of arrangement, and hence gas and liquid will pass through this valve. So just I am going to show you with the help of animation. You can see that gas is passing but it is restricted. Now if gas is flowing from other side, it is allowed to pass. So I hope this is clear. So now moving next, spring loaded check valve. As for function wise, both valves are same, but only the difference is it has spring for the positive closing of the valve. Its function is also the same, allows flow in one direction and blocks flow in other direction. This is the illustration in which you can see this is the spring and this is the valve. And if gases or liquid passes through here, then it will lift the valve and it will travel all along the other side. But if gases or liquid passes through here, then the pressure will act over this valve and it will cause to seat the valve against its valve seat, and hence it will restrict the flow of gases or liquid. So now I am going to show you with the help of animation. So you can see gases is passing through this way, but if it is passing through this way, it is restricted. Okay, moving next, we have already discussed about the shuttle valve, so we will discuss about the end valve. Function of this valve is only when both the inputs are given, output is produced. That means if input is given from here and from here, then you can take output from this port. And similarly, if input is given from here and here, then you can take output from this port. So this is how this AND valve works. Now you will be curious that where this sort of valve is used. So in most of the ME engine control air system, you will find a dryer. In this dryer, at this place and at this place, this AND valve is used. So if you know in and out of this AND valve and its functionality, then it will be easier for you to do maintenance related to this valve and this valve. Now I am showing the animation of AND valve so that you can understand. So suppose I am giving input from this port, then this port will be closed and it will open this port to this port, and hence the output can be taken. Similarly, if this port is pressurized, then this valve will be closed and it will allow gases or liquid to flow from this way. So this is how this AND valve works. Now our next valve is quick exhaust valve. The graphical representation is like this, and the function for quick exhaust of air to cause rapid extension retraction of cylinder, and this valve is widely used in MC engine pneumatic circuit. It will look like this, and now I am going to show you with help of animation that air comes from here. It lifts the valve so that it chokes this port and it passes from this port. But when pressure drops, then this valve falls down and all trapped air over this port will release through this port quickly. So that is why this is called the quick exhaust valve, and it is mostly used where the cylinder are used. For example, main starting air operating cylinder. Now we are going to see practical aspects of all valve which we have discussed so far in MC engine maneuvering diagram. This is the MAN B&W MC engine pneumatic diagram. Now you can see over here, this is pneumatic valve, this is also a pneumatic valve, this is the quick releasing valve, this is check valve with restrictor, this is roller operated valve, this is manual valve, this is symbol of manual, this is detent, this is shuttle valves, this is also non-return valve with restrictor, this is pneumatic valve, 3/2A valve, this is also pneumatic valve, this is detent, this is quick releasing valve, this is electrical operated valve, you can see electrical line is given, this is also having a quick release function, this is spring loaded check valve, this is manual valve with detent, this is check choke valve or shuttle valve. So I hope that you are now familiar with all type of valve which is used in MAN B&W MC engine. If I talk with respect to ME engine pneumatic diagram, then we can find that very less amount of valve is used compared to MC engine pneumatic diagram. Now I am assured that you are well familiarized of all type of valve which is shown in this diagram. Now coming to next topic, that is generalized and detailed symbol. So we will understand it by a diagram. While reading some pneumatic diagram, it may possible that you come across with this kind of symbol by which you get nothing other than it is 2/2A valve. But as far as reading pneumatic diagram is concerned, you will not face any problem. In detail symbol, you will get all the information related to that valve. For example, this is exhaust port. This pneumatic valve is electrical operated. Pipeline is connected with this position of this valve. That means it is normally closed type. Next, this is pilot operated type. This is also a spring return type. It is also having manual override. So lot of information we can get in detail symbol. But sometime you will find generalized symbol is used in pneumatic diagram. That's why I have covered this chapter. Our next topic is how to read pneumatic diagram. There are some standard practice which is followed globally in terms of pneumatic diagram. So let's see. Any pneumatic diagram is represented in depressurized condition. Second, without power. Third, all electrical equipment in de-energized condition, but sensor will be in working condition. Sensor means our temperature, pressure, switches and transmitters. That means in completely dead condition. So these are a standard practice which is followed globally in terms of pneumatic or hydraulic diagram. If any condition is applied, it must be highlighted. For example, I have represented over here MEC engine pneumatic diagram. Here at the right bottom corner you will find there are some condition written over here. So it is already highlighted that the diagram shows the system in following condition. A stop position means engine is in a stop condition, pneumatic pressure is on, electrical power on, main starting valve in service position. This main starting air valve is in service position. So in this case some conditions are there which is already described. If this condition had not been there, we would have assumed that this is the standard condition which must be applied in this pneumatic diagram. I hope this is clear. Now moving next. How to read circuit diagram for connections of pipe. This is very important because lot of people get confused in reading the connections of pipes. So I am going to elaborate in detail so that you can have a fair understanding related to reading the diagrams. So there are mainly three types of format is used to represent the connections. So I am going to introduce all type of formats. First one is format number 1, which is without dot with crossover. Regarding this dot and crossover, I will explain in a while. Suppose there are two lines. This is like this, that means without dot. Then we can understand that this is connected. This line is called crossover line, and meaning of this line is it is not connected with this line. That means it is bypassing this line. Next format is format number 2, with dot without crossover. Suppose these two lines are there and there is a dot present between these two lines. So this is representing that these two lines are connected, and here other line is without crossover. That means it is not connected. So now just see these two picture. In format number 1, this line and this line was not having dot but was having this crossover. That means we can understand that these two lines are connected and these two lines are not connected. But in format number 2, since dot is present, so it is representing that these two lines are connected while these two lines are not connected. That means this line and this line are bypassing each other. Next format is format number 3, with dot and with crossover. So it is representing as usual that line is connected and this is crossover, so representing not connected. So mostly in any pneumatic diagram you will find these three type of format, and if you know how to read the connection of the pipelines, then it will be easier to understand the pneumatic diagram. Now moving next, we will see some examples. So first example is this one, we have already seen before. You can see here some dots are present but crossover is not present. Crossover should be here, but crossovers are not being displayed. That means this circuit diagram is with dots without crossover. Dot is present and crossover is not present. Next example is, in this diagram you can see dot is not present. It is showing that two lines are connected and crossover is present. That means this is without dots with crossover. Dot is not present but crossover is present. Related to this diagram, I will show with animation so that you can understand that how actually a small pneumatic circuit works. About this I am just explaining once again. This is called the sintered filters. and they are used for the exhaust purpose. So these are the center filter used for the exhaust purpose. In this diagram you can see there is no spring given, that means they are not a spring return type. Also two solenoids are given, this side and this side. Also you will find two detent are given. The meaning of two detent is, suppose this solenoid get active, then it will push the spool to this side and it will be remain in that position even though solenoid is de-energized. And same thing is with this solenoid too. That means the spool inside of this valve is of floating nature. This type of valve is also called bistable valve. That means it has stability over two positions, and that can be achieved if and only if a spring is not there. Okay, moving next, we will see next example. In this pneumatic diagram you can see there is no dot present but crossover is present. So it will be example of without dot with crossover. Another example, this is the hydraulic diagram. In this diagram dots are present and crossover is also present. That means this diagram is of with dot and with crossover. I hope this much is clear. Now we are going to see next. Now as I told you before that I will brief this pneumatic circuit and I will also explain with help of animation. Alright, so now this is main supply air. This supply air is going to valve number 1, and if this valve number 1 is operated, then air will reach to valve number 2 and thereby it will go to valve number 3 and we will do pilotage from here. This pilot air is showing that when pilot air will be present over here, then also pilot air will be present over here. Okay, now this air is acting over here from the underside of the piston and holding the piston in this place. Air will be released from this way, or when the valve will shift, then air will release from this way. Now I am going to explain this circuit with help of animation. Before showing the animation, I have one suggestion for you, that you have to practice with a small pneumatic circuit and then try to read little more complex circuit. That will boost up your confidence. So please do read different type of pneumatic circuit, because I will just explain this a small circuit, but you have to practice to read more complex circuits so that you will have better idea. So let's start. This is the animation part. I am going to operate this valve. So I have operated. Now air will reach to here. It will wait, and when I will operate this valve, then air will reach to here. It will do pilotage and air will start going like this. Now the reverse process, I am just taking off this hand. So if I remove the hand, now air will act, this valve will lift and it will act from downside of piston, and this area trapped air will be released from this sintered filter. Now by observing this animation, you will have better understanding about how a pneumatic circuit works. In complex circuit, you have to trace the line, pipe connections, and also you have to check about the operating mechanism, pilotage, spring return, like this, etc. And you will be able to understand the whole circuit diagram. The next topic. There are two major components found in pneumatic line of ME engine. First one is pressure reducing valve and second is pressure relief valve. So first we are going to see pressure reducing valve. So this is a diagram of pressure reducing valve. I am just summarizing its internal parts. This is adjusting handle. This is the adjustment spring. This is the diaphragm, this black color. This is called a stem, which basically connect the diaphragm and this poppet. Poppet is basically a valve and nothing else. And this is called the poppet spring. This is the inlet and this is outlet. How does it work? There is a set point of this pressure reducing valve. Suppose inlet is at 30 bar and outlet is set at 8 bar. So once the 8 bar pressure reaches, then the pneumatic pressure acts from the downward and it pushes the diaphragm up, and thereby it closes the valves, and hence pneumatic pressure start reducing. Once the pneumatic pressure start reducing, then this area pressure reduces and a spring force act on the diaphragm, and hence it pushes this stem and cause this poppet to open. This is how the pressure reducing valve works. Now I am going to show about its symbol. The whole pressure reducing valve is represented in this form. This is the spring, and this arrow means I can adjust the spring pressure by this adjustment screw. This is the inlet port and this is the outlet port. This inlet port is this one and this is the outlet port, this one. This line is showing that pilotage is done by the outlet pressure, not inlet pressure. This arrow is indicating poppet. Now the meaning of this symbol is that if this poppet is closed, that means the inlet port and outlet port are isolated, and if this poppet is open, then inlet port and outlet port are connected. So if this arrow is in line with this one, that means these two ports are connected. That means inlet air is being supplied to outlet, and if this arrow is down, that means this port and this port are closed. There is no airflow from inlet to outlet. So this is representing this one. Next example, this is also a pressure reducing valve. In this pressure reducing valve, you can see valve is open. That means inlet air is going to outlet port. So this will be represented like this one. This poppet is open and thereby inlet port and outlet port are connected. I hope the basic function of pressure reducing valve as well as its graphical representation is clear. Now I will show you with help of animation that how actually this pressure reducing valve works. So this is the animation. I have already explained that how does it work. Just I am showing with the animation over here. At present this valve is open. That means these two ports are connected. Now when the pressure will rise, that will cause this valve to sit, and hence this will close the port. See, now this has closed the port. Now as the pressure is reducing, it is opening the port. So you can see over here, this is frequently opening and closing the port. So this is how the pressure reducing valve actually works. This valve and valve seat is frequently getting closed and open. That is how this pressure reducing valve maintain a constant pressure over here. Now we are going to discuss how to solve problems related to pressure reducing valve. This is the same picture. I have already explained its internal part. Sometimes the outlet pressure is keep on increasing and hence cause to lift the pressure relief valve. So in that case you have to sort out the problem of this pressure reducing valve. So now I am going to show you how will you sort out the problem. So first of all you have to see the condition of diaphragm. If diaphragm is ruptured, then you will obviously get air pressure over here from this telltale hole. So first of all you have to replace this one. Second thing, this spring and this spring might damage, that you can see visually. Next thing, this is the valve seat. Mostly there is a problem in valve seat only. So valve seat look like this one. You can see the valve seat area where this part actually sits on this valve seat are damaged. In this condition, obviously there will be air leak and it will cause to keep on rising the outlet pressure. In that case, you need to change this seat area. So there are only few things in the pressure reducing valve which you have to see one by one, and you have to take the necessary action. So if there is a problem with related to pressure reducing valve, then you can easily solve the problem. Okay, now moving next. Next thing, pressure relief valve. So pressure relief valve look like this. The graphical representation of this pressure relief valve is like this. This poppet is regulated by the internal air pressure, and if you see its internal construction, then it look like this. This is valve, this is shown by this one, and inlet pressure acts over here. If pneumatic pressure increases above its set points, then this valve lifts against the spring pressure and excess pressure get released into atmosphere. So this is very simple. In this diagram you can see this is poppet, means valve. At present this valve is closed, that means this outlet port and inlet port are not connected, but when pressure increases, then this pressure lift this poppet and excess air get released into the atmosphere. I hope this is clear. Now this is the end of part 1. In the part 1 we learned about basics of all pneumatics. Now in part 2 we will see the practical aspects of what we have learned in part 1. For example, we will read about MEC pneumatic diagram, its components. We will see with the whole pneumatic system working with help of animation. Also we will see some troubleshootings and case study. So after that, please see part 2.